Hi, this is Amin, and hopefully this is the last episode of the BGP concept. And after that, we're going to work on the GNS tree in a real scenario, and we will learn more and more, better and better. So we know what? We know that the dynamic routing protocols, they are working based on some policies. For example, RIP routing is a distance vector routing, and it is searching for the shortest path to share the data, or EIGRP is searching for the highest bandwidth to communicate via that link between all the links which are available. But here in the BGP, we have BGP attributes, AS path, next hop, origin, local preference map, and other attributes. So these are the things that a router will decide based on them to share the data or to communicate with the other routers, or we can say to advertise the networks through the net. So what are those? If you're preparing yourself for the CCNP test, so it is good to learn the names, to memorize them, and to try to memorize the meaning of them. But if not, just try to understand the concept. It is enough for you. We're not going to go deep through them. The slides are here. You can pause the video, read all of them. But well known, for example, as its name is telling us, it is well known. So all of the routers, they know about that. And it's sort of mandatory. All of the routers are propagating this to the neighbors, or optionals is something not mandatory. Mandatory is something you cannot eliminate from that. On the show IP BGP summary, you'll see that, or the rest of them. Okay, let's save some words. Go to the attributes one by one. AS path attribute, list of autonomous systems that a router will travel. A route will travel or will pass. How, for example, here router A is going to advertise this network 192.168.1.0 to the router B. Here the transit AS is this AS. So on the router B, we'll see something like that. These two AS numbers. That I think on episode 1 or 2, I've told you about that, which is the AS path will prepend. And it's kind of well known, and it means all of the routers, they know about that. It is mandatory. Good. Next hop attribute, and again I've told you about next hop, and I tried to come up with the same example in order to somehow some sort of review for you. But the next hop is this the same concept that I've told you on the episode 2 or part 2, which is the interface that a network is going to leave a router will be the next hop for that. And here it is the same example. It's also well known and mandatory. Origin attributes, it means the router or the network is originating via which command. If it is originated via network command, we will see this I'm going to show you, unless you will see this question mark, and also it is well known and mandatory. Okay, look, show IP BGP, and this is the result of that. Look, I've told you about the next hop, so we'll see the next hop here. The metric, look, this is the I. So this I means IGP, means it is based on the network. This is the thing that I think you won't see that, but in the old some sort of routings based on that commands, it was, but now we just see what this I and this question mark, and this question mark, it means that network is generated via redistribution to the BGP. So it is incomplete. It's not the BGP, or it's not based on the BGP commands. So look, these I's, yeah. Anyway, local preference attribute. What is the local preference? This one is well known, but this one is not mandatory. So the three things that we've seen so far, they were mandatory. This one is not mandatory, and this one is by default 100. Look at this scenario. We have this, for example, this cloud of network is our AS, and we have two routers, and we can access this AS via this path and also this path. But what do we do here? We can set this number, local preference 200 here for this router to reach this AS, and local preference 150 to this router to reach this AS. What does this mean? In this way, we are telling to the network, my local preference, my preference is that whenever you wanted to reach the AS number 65 here, 6535, whenever I want to reach this AS, I rather this path. So my local preference, the higher means the more priority here. If you do not mention that, by default is 100. Otherwise, when you are changing that, the higher is the more priority. So in this way, whenever you want to communicate, if you can remember on HSRP, we have something like permission, and we add priority to one of the switches in HSRP scenario or protocol. So here it is somehow this, and we are saying that my preference is this router to reach this AS. So we can change that. What is the mid? In a different way, here the lower has the higher priority. And how? This is for this scenario. You are at this AS and you have two different uplinks to one service provider. So in this way, you're gonna tell the edge routers of the service provider, my MED, my net here is 150 and here is 200. To me, there is no difference. I'm gonna communicate with you maybe via either this link or this link. But whenever you're gonna respond me, whenever you want to share something with me, please share via this link to me. So this is the concept of MED. Look here, the higher, the more priority. Here, the lower, the more priority. And if you forget that, you can somehow say that it's like a metric. The lower, the better. So it is optional. It is non-transitive. And wait, it is only for Cisco. It is for this scenario. You are here, but you have, look here, there was the same service provider, two uplinks, but here two different service providers, two different uplinks, and it is somehow like what? Like the first one, local preference, the higher the better. So you're gonna set a weight whenever router A or me, whenever I want to share something to my uplink, whenever I want to advertise my a network or something which is here to this AS, I'd rather this path. And this is the concept of weight. So far we know about them. How a router will decide about that. So let's take a look at them. Consider only routers, with no IS loops anyway. First thing prefers the highest weight. So if just there's a Cisco routers, not Brocade, not Juniper whatsoever, first it goes for the weight, and then it goes for the highest local preference within the AS, and then it goes for the next hop. So this is, for example, this one has the highest priority, and then shortest AS path. We know that about the AS path that is gonna prepend all of them, so the shortest here is the better, and then after that it's preferred for the origin. So first IGP, then EGP, which should be E, and then incomplete, which is a question mark. Then prefer the lowest mid exchange between the autonomous systems, and then prefer eBGP over the IGP path. Then prefer path through the closest IGP neighbor, and prefer the oldest, the first eBGP that you have. And I think from this one you can manipulate that, you can change that. But from this place downwards, from 7, 8, 9, 10, 11, these are the things that the router will decide. So if you want to change that, you can change it before the router decide for that. For example, prefer the path with the lowest neighbor BGP router ID. Or, we know that, for example, in the OSPF, router ID was important. But here, we'll see, no, it's not important. I mean, between 11 steps, it is at 10. Or prefer the path with the lowest neighbor IP address. So, what is the next? This is a summary about AS path, about the next hop, about the local preference that I've told you. If you want, you can read that. But anyway, this is a summary to what I've said. So let's see the commands. Route map to manipulate basic BGP paths. BGP is designed to implement the policy of routing. So look at this. When you when you want to have an uplink, so you're gonna buy that. You're gonna pay for that. So it will be important for you. You need to do some sort of load balancing, or whenever some kind of traffics are important for you, you need the higher bandwidth to have a good continuity of service, to have good speed, something like that. But maybe this is the thing that you will encounter. Look, they are unbalanced. 60% for the uplink, 10% for the downlink, or something like that. So you need to change everything. So changing BGP local preference for all the routers. At first, config to the router, so router BGP your AS path, and then BGP default local preference value. So in this way, you can change the local preference. Just by adding a value to that, this command changes the default IBGP. How this is the scenario, and then we'll see. So here, imagine you're at the router C, and from the router C, we want to advertise the network which is behind the router C to the router Z, which is here. There are two paths. One of them is here, and one of them is here. If we take a look at that, what do we have here? Router C BGP table. So here we'll see, to achieve this network 172.30.0.0, 172.30.0.0, we have two paths. The first thing was weight of all of them are 0, so nothing. Local preference is 100, the same. And then let's what else remains? Okay, here we have the path, and this sign or this mark that I've told you, it shows the best path. And we'll see here the lowest AS path, which is here, is going to tell you this path is the best path. But how we can change that? Look, this is the configuration of the router A. Look, router A, router BGP, this is the AS path of the router. And then we have the neighbor 222, neighbor 333, update source loopback. These are the configurations. Look, this is here. So 222 is for the router B, 333 is for the router C. So it has it has a fully meshed IBGP, and then also it has what? It has for this one, for the eBGP, this network, and also we have what? A neighbor 192.168.28.1 remote AS65.002, which is here, and neighbor 192.168.28.1 route map local preference. It's a name inbound. So it means what? We're gonna tell that to that path, to that neighbor. You need now you have a route map with its name is a local preference or local pref, which is inbound for your inbound traffic. I mean, for whatever is going from here. And we need access list for that. Access list number 65, permit this network with the mask. So what do we need here? We have one IP access list after that, and then route map local preference permit 10 match with IP address 65, which is the number of this access list. So this access list number will be here. And then set local preference 400. I've told you the more number in the local preference would be the higher priority. So what do we have here? We have the command of a neighbor route map inbound, and then we need the access list for that. And after that, we have a route map, local preference permit, and match the IP addresses towards that access list. And the local preference now is 400. What will happen if we do show IPBGP? After that, we'll see this sign now is here because of what? Because of this local preference number, which is now 400, even though the AS path is more, but the local preference has the highest priority, and we've changed that here. So changing BGP MET. So now let's think of MET for that. What do we need to the router BGP? AS number and default metric number. So in this way, we type default metric and change the number. How? Let's see. This is a scenario. Look, we're here, and we would like to connect. We have two uplinks to this AS, and in this way, look, we have network and MET. Here, I've told you the lower the better, so I've changed that in a way. These two networks, they can go or they can be advertised to the router Z via this link because their MET is lower than this one. And here, look, this one is 200 and this one is here 100. How with this command, we're gonna see the router A, neighbor 222, neighbor 333, which are these two for IBGP, and neighbor 192.168.28.1 for EBGP. Look, the same. IP access list 66 permit that network and this network, and then route map MET. This is a number, and I've chosen that in a way that look here, in order not to be confused. I've chosen this AS path. So this is just a name, MET underscore 65004 permit 10 match the IP address 66, which is my access list, and then set a metric. And then after that, I came up with another route map with different number and changed the metric. And exactly in router B, the situation is vice versa. So I've done the same, and the EBGP port is here, and then IP access is 66, and totally the same. So in this way, we can tell via which interface or via which next hop the network will be advertised. So let's go for the router Z. On the router Z, if we show IPBGP, we'll see, look here, for 192.168.24.0, which is here. The MET is 200. The best path is what? Is here. Look, the best path is here from 170 to 2050. 170 to 20. Look here. So for this network, because the MET is lower, the best path is here. But for the rest of them, I mean for these two networks, the best path is this one. Why? Because of the MET number. So in this way, we can change the MET. And okay, let's go for the summary. Now we know how to manipulate the MET, change the local preference, and how to somehow manage, or manage is better, or control. Control that. Anyway, so the last thing is the IP prefix list, which is another thing that we need to learn. We have IP access list and we have IP prefixes. All of you, I'm sure all of you know about the IP access list. There are many things that you can maneuver. We have IP accesses standard, extended, and extended. You can even work on the port, which port or which protocol, for example, Telnet, HTTP, I don't know. You can block a port, something like that. And it is more, I'm not going to say powerful, but you can maneuver. But in scenarios like BGP, that you need to work on the subnet masks, IP prefix list is better because you can work on your subnet masks. But the concept of them are totally the same. Even you have permit, you have deny, and for example, when you permit something, the rest of them will be denied, something like that. So the concept is the same, the commands are somehow the same, but here you can work on the subnets. For big networks that you have lots of networks, when you can do some sort of management on the subnet, it is definitely better for you. How? Look on the global configuration mode, IP prefix list name, so you're going to come up with a name, then sequence, permit or deny, and the network or the length, and you can say greater or less. This is the thing which is different. How? These are some examples. Look, the description is here, but let's see the examples. Which of the following routes will be matched by? IP, look, this is the command. IP prefix list my list, this is just a name. Permit this 192.168.00/16. It means exactly this. So whenever I say 192.168.00/16, it means just this. Neither this, nor this, nor nothing. Just this one. I would like to have the permit just to this network. But here, which of the following routes will be matched by, look, IP prefix list, my list, the name, permit 192.168.00/16, less than 20. What does this mean? It means this network, 192.168/16/20, whatever is less than 20 is acceptable for me. But /24, which is greater than that, is not permitted. Or IP prefix list, my list, permit 192.168.00/16 greater than 18. Maybe at first glance, it is weird. It will be weird for you because you're gonna say 192.168.00/16, but greater than 18. Even that specific network is not allowed, is not permitted. But this is the concept that you can work on that. You can change the subnet. It is perfect. This is your main network, but you can do the manipulation. You can change the subnets. So there are two ways for that. You can look for the prefix list. Look at here. Set router. After having the command, in this way you're gonna add the prefix list to the router BGP. So neighbor, look, router BGP autonomous number system, neighbor IP address or peer group name, then the prefix list. This is part of command, this is the name. So the prefix list and the name, inbound or outbound. Or you can use this way, in the route map, go to the route map and match the IP address prefix list, and neighbor in or out. Like the way that we add the access list for the med or the things that we've had, we've added them by route map. We can here use either by route map or with this command. Both are correct. Okay. And this is the summary of the module and the summary of whatever I've said in this video. And yeah, whatever I wanted to say is finished. Just a route reflection is one part which is missed, that I'm going to make a video about that pretty soon, but not now. So now we know all of the concepts about the port of the BGP, about the, the way of the communication, about the priorities. And then after that episode, I'm going to make a video on GNS3 and will show you a real scenario how to type the commands and see their logs and results live. So if you enjoyed these 3 episodes, just show a thumbs up and hit on the like button. If not, thanks for watching the video. Don't forget to subscribe to the channel, and please watch the upcoming video, which will be the part 4. Bye everyone, stay tuned.